Hi, in this video, I will be showing you problem number 13 of chapter 7, section 1. Evaluate the integral t cosecant squared t dt. So we will be applying integration by parts, which is integral u dv equal to uv minus integral v du. So when we pick u and dv, we can use the mnemonic, which is Learte. So here in this function, t stands for algebraic, and then cosecant squared t stands for a trigonometric function. So here in the Learte rule, a occurs first, t occurs after. So a, algebraic, is the good choice for u. So we will pick u equal to t, and then dv equal to cosecant squared t dt. Then we have to do du, which is derivative of u, which is dt. Then we have to do v. From dv we have to get v, which is integral of cosecant squared t dt, which is negative cotangent t. So we have du, we have v, we have found out v. So we'll apply in the integration by parts rule. So integral t cosecant squared t dt, which can be considered as u dv. So we are making it look like this rule. So which is uv minus integral v du. So u is t, v is negative cotangent t, minus integral v du. V is negative cotangent t, then du is dt. So it is negative t cotangent t, minus and minus, so plus integral cotangent t dt. If you don't remember the formula for integral cotangent t dt, we can actually derive it, which is not that hard here. So t times cotangent t plus integral. So cotangent t can be written as cosine of t over sine of t dt. So if we call this one, if we specially integrate this one as I1, and we call it I1, and then we'll find out what that I1 is, which is integral cosine of t over sine of t dt. We'll evaluate this and then get back to this step and plug in the value of I1. So now we are going to apply ordinary substitution rule over here. So we will take u equal to sine t. So du would become cosine of t dt. So I1 is integral cosine t dt. The numerator is simply du, and then denominator is u, which is ln of absolute u, or ln of, if you substitute back for u, which is ln of absolute sine t. So that is the value of I1. We are going to plug it back into this step. So the original problem, which is integral t cosecant squared t dt, which is from step 1, is negative t cotangent t plus I1, but we got I1 equal to ln of absolute sine t. Don't forget the constant of integration because it is an indefinite integral. So that is the answer to the problem. Hope this video helps.